With 974 massive steel shipping containers, Qatar built one of the most unique stadiums in World Cup history. Each container crossed oceans before being stacked and linked together, forming a stadium that holds nearly 40,000 spectators, designed to withstand Gulf heat exceeding 50 degrees Celsius. Behind this seemingly improbable structure lies an investment of about $175 million and a radically different approach to construction. This stadium doesn't chase being the biggest, it follows a different philosophy: maximum flexibility. Every container acts like a module in a giant machine, ready to be dismantled, transported, and reused anywhere in the world. So is this just a World Cup stadium? Or a sign that the era of permanent concrete is slowly coming to an end? This story will keep you watching. Under the lights of the World Cup, every stadium is a reflection of ambition, technology, and the spirit of its era. Since the very first match in 1930 in Uruguay, the tournament has been more than a football stage. It has also been a platform for nations to showcase their organizational capacity and construction vision. When Qatar won the right to host the 2022 World Cup, it sent shockwaves through the global construction industry. When Stadium 974 was unveiled, it drew attention not only for its bold modular design, but also for the people behind it. Thousands of migrant workers, mainly from Nepal, India, Bangladesh, and Pakistan, took part in building the stadium under harsh climate conditions, earning typically $1 to $2 per hour while working 10 to 12-hour shifts each day. This largely unseen, behind-the-scenes reality turned the project into the center of intense social debate worldwide. Amid the scorching heat of Qatar's desert, the planning phase for a perfect World Cup stadium quickly became the greatest challenge for architects and engineers. Daytime temperatures could soar beyond 50 degrees Celsius, yet once night fell, dry cold air and strong winds took over, often bringing sudden sandstorms. Long before any final drawings were approved, teams spent years surveying the terrain, studying soil conditions, wind patterns, and heat radiation to ensure the structure could survive such extreme conditions. The design concept began taking shape early on and was repeatedly refined through countless simulations and tests, until a solution emerged that could guarantee safety and comfort for spectators while also reflecting Qatar's ambition for innovation, eventually becoming ready to move into the construction phase. As soon as the site work began, the greatest challenge became clear beneath the ground itself. The Ras Abu Abud area is reclaimed coastal land with loose sand, low compaction, and a high groundwater level, making it almost incapable of bearing loads naturally. Engineers were forced to level the site on a large scale, remove weak sand layers, and reinforce the ground with hundreds of reinforced concrete piles drilled 20 to 30 meters deep, creating a stable foundation for a structure covering more than 200,000 square meters under the harsh conditions of the Gulf. On this foundation, the steel framework was erected like assembling a giant machine. The main structural system uses high-strength structural steel, rising to a height of around 40 meters and enclosing the stadium space across hundreds of thousands of square meters. Columns, beams, and steel trusses were prefabricated as modules, then transported to the site for assembly and connection using thousands of load-bearing welds and high-strength bolts. Every joint had to withstand coastal winds, extreme day-night temperature expansion, and the heavy weight of the container blocks above. This steel frame became the backbone of the entire project, allowing the stadium to be both structurally robust and fully aligned with its modular construction philosophy from the very foundation, while also being designed for dismantling and reuse without compromising safety or structural strength. In parallel with the erection of the steel frame, the stadium's exterior gradually took shape through the stacking of shipping containers, the defining feature that gives the structure its distinct identity. A total of 974 steel containers were directly integrated into the structure, forming an industrial fortress that wraps around the stadium. Throughout construction, the containers were installed in sync with the steel framework, stage by stage, rather than being added after the main structure was completed. Each container was precisely positioned, serving not only as a secondary structural element, but also as functional space for stairways, technical rooms, service areas, and access routes to the stands. The number 974 was no coincidence. It is Qatar's international dialing code, intentionally encoded into the design as a national signature. Stacked in multiple layers at varying heights, the containers give the stadium's exterior the appearance of a modern industrial stronghold. Steel boxes that once crossed oceans were reborn as architecture, turning the construction process itself into a rare display of engineering ingenuity in the history of the World Cup. Hidden beneath the stadium's surface is a drainage system built with near-absolute precision. Straight, deep drainage trenches were cut into the reinforced sand base, wide enough to accommodate large pipes with diameters of around 400-800 mm, made from HDPE plastic or load-bearing composite concrete. The pipe sections were connected along a technical slope of about 1%, ensuring rapid water discharge even during rare but intense desert rainstorms. Before backfilling, each trench was lined with waterproof membranes and geotextile fabric to prevent fine sand from entering the system and causing long-term blockages. Excavators, rollers, and grading equipment then worked in coordination to compact each layer of backfilled soil above the pipes. Remarkably, the system was designed to handle large volumes of water within just a few minutes, despite Qatar's infrequent rainfall, reflecting a mindset of preparing for worst-case scenarios in high-end infrastructure engineering. A football pitch is not just the grass visible on the surface, but the result of a complex technical system operating quietly around the clock. At this stage, the entire infrastructure is ready to accommodate the undersoil heating and sub-air systems, two technologies that play a critical role in controlling the pitch's growing environment. Polypropylene pipes are arranged in parallel lines, evenly distributed across the entire field at a depth of about 25-30 cm, forming a precise and uniform thermal circulation network. In cold weather, warm water continuously flows through these pipes to keep the soil temperature stable at around 12 to 15 degrees, preventing frost formation and protecting the root structure from damage. By contrast, during periods of intense heat or high humidity, the sub-air system functions like an artificial breathing system for the pitch. Excess heat and moisture are drawn out of the soil, while cooler air is pushed down into the engineered soil layer, keeping the surface dry, firm, and well aerated. In Qatar's harsh desert climate, choosing the right playing surface is a matter of survival. The country uses hybrid Bermuda grass because of its exceptional heat tolerance, rapid recovery, and ability to withstand a dense match schedule. This grass is grown in specialized turf farms, where sunlight, irrigation, and nutrients are precisely controlled to produce a perfectly uniform and resilient playing surface. Once the grass reaches its optimal maturity, it is not cut into small sections but harvested in large rolls, preserving the root system and the soil structure beneath. Specialized machines carefully lift the entire turf layer, roll it up, and transport it directly to the stadium within just a few hours, minimizing biological shock. Thanks to this process, the turf settles almost immediately once laid onto the pitch, allowing the roots to establish quickly and making the surface ready for top-level competition. After the underground infrastructure is fully completed, the automatic irrigation system is installed to stabilize soil moisture before the turf is laid. Pop-up sprinklers are buried and arranged in a precisely calculated grid, ensuring water is distributed evenly across the entire playing surface. Water pressure, spray angle, and irrigation cycles are centrally controlled and connected to soil moisture sensors and real-time weather data. This allows irrigation levels to be adjusted to the hot, dry climate, keeping the engineered soil properly moist without causing waterlogging or disturbing the ground structure, creating a stable foundation for turf installation. Immediately afterward, the turf installation begins with an almost surgical level of precision. Mature grass is delivered in large rolls and laid in long, continuous strips to minimize seams and create a seamless playing surface. Each roll is carefully aligned to the designed elevation, with tolerances of only a few millimeters, ensuring proper flatness and the exact slope required for match-grade drainage. Once the entire pitch is fully covered, lightweight rollers are used to gently press the turf into place, allowing the roots to make uniform contact with the soil beneath and helping the grass establish quickly. The irrigation system then switches to short, frequent cycles, maintaining stable moisture levels around the root zone without disrupting the soil profile. During the first several days, irrigation, ventilation, and temperature settings are tightly controlled, allowing the turf to gradually stabilize and develop a surface that is firm, resilient, and visually uniform, capable of meeting the demands of high-intensity professional competition. In parallel with the completion of the playing surface, the largest construction workload of the stadium takes place in the grandstand structure and spectator facilities, the elements that ultimately shape the experience of tens of thousands of fans. The primary structural framework is built using high-strength steel and reinforced concrete, with precast grandstand modules assembled tier by tier. This approach significantly shortens construction time while maintaining strict structural accuracy. Seating rows are then arranged according to carefully calculated sight lines, ensuring that the distance from the farthest seat to the touchline remains within international standards, typically under 190 meters, so every spectator enjoys a clear and unobstructed view of the action on the pitch. Above the seating bowl, the roof structure is completed using lightweight steel components engineered to carry heavy loads. Spanning dozens of meters without internal columns, the roof shields spectators from intense heat and heavy rain, while still allowing natural light and airflow to pass through the stadium. At the same time, a wide range of functional spaces are finished within the grandstand structure, with special attention given to VIP and hospitality areas. These spaces are designed to resemble high-end lounges, featuring dedicated seating, private viewing areas, food and beverage counters, independent climate control systems, and direct sightlines toward the field. In addition, the stadium is equipped with a high-power LED lighting system installed along the roof structure and grandstands to ensure uniform illumination across the pitch and spectator areas. The lighting meets international broadcast standards, with brightness levels exceeding 2,000 lux for high-definition television coverage in night matches. The system is centrally controlled, allowing multiple lighting modes while optimizing energy use and maintaining stable operation, even with crowds of over 40,000 spectators. After years of construction and careful completion, the stadium was officially inaugurated and entered full operation, marking the moment when this massive engineering project truly came to life. The grandstands that once existed only on blueprints began welcoming tens of thousands of spectators, while the pitch itself became the stage for top-level football matches. During the 2022 FIFA World Cup, the stadium hosted several key fixtures, where the pace of play, lighting, sound, and emotion blended into the electrifying atmosphere that defines the world's biggest sporting event. At this World Cup, global football witnessed one of its most emotional stories as Argentina claimed the championship after a dramatic journey, crowned by a thrilling final. The celebrations, roaring crowds, and unforgettable moments shared by players and fans alike transformed the stadium from a purely technical structure into a place of collective memory, where each match was recorded not only through goals, but through history itself. Maintaining a stadium pitch in perfect match condition is a process that tightly combines mechanical engineering with precise agricultural science. The surface is regularly aerated using specialized machines to relieve soil compaction, allowing air, water, and nutrients to penetrate deep into the root zone, supporting healthy root development and improving drainage after heavy rain. At the same time, mowing is carried out under extremely strict standards, with grass height typically kept between 24 and 28 millimeters in accordance with UEFA and FIFA regulations. Cutting is not only about controlling height, but also about visual performance. Specialized mowers bend the grass in opposite directions across adjacent strips, creating light and dark stripes through differences in light reflection. However, to ensure fairness and visual consistency for players, top competitions allow only horizontal or vertical striping patterns, requiring the entire maintenance process to remain tightly controlled under international standards. From a harsh desert landscape, where intense heat and blowing sand were once seen as enemies of football, a modern stadium has been created as a complete living ecosystem. Beneath the green grass lies a massive technical machine operating continuously, controlling temperature, moisture, and every fine detail to ensure each match can unfold at its best. When the ball rolls across the pitch, it is not just a sporting moment, but the result of science, engineering, and human ambition working together. If you want to explore more of the technology hidden behind world-class structures and major events, don't forget to like the video and follow Mandarin Tech to join us on future journeys.